Right now, we are looking at the dawn of a new era of aviation.
Something has now emerged that might make even our most elegant theories workable.
Scientists developed equipment which would be able to think.
Machines that do things and make choices without human beings. That uncanny spectacle is automation. Capable of storing, processing.
Calculations that would ordinarily take hundreds of man-hours. Unique ability to check itself on possible errors.
Cheaper and quicker and better. Electric eyes, limit switches, servo mechanism.
Secretary, librarian, banker, teacher, medical technician, bridge partner.
Volumes of changing data into a continuous flow of interpretation. Aladdin's lamp couldn't do more.
Jaws, loading machines, electric drills, it's all automation.
Computers have taken wing.
By the late 1960s, digital computers had become more available.
Using data about the aircraft's performance, the computers vote on the correct amount of control deflection to make in response to the pilot's stick and rudder movements.
This system could make air travel of the future smoother and safer by reducing aircraft vibrations through automatic response from the computers to the aircraft controller.
We did the digital engine control. We had an early large digital computer that ran the engine and the inlet and exhaust system.
We did an integrated control study to provide digital control of the inlets, autopilot, throttle, air data, and navigation system. Our digital computer here, major improvement in capability of the airplane.
Test pilots are flying a plane without having to leave the ground. It's a new way of flight testing advanced aircraft that's both more economical and less hazardous. A research pilot in a realistically recreated cockpit on the ground, complete with flight controls, flies the remotely piloted craft using computers and television.
The airplane includes computers. Those computers take stick command and
continuously monitor what the airplane is doing and compares it to what the pilot wants the airplane to do.
The computer signals the control surfaces to not only execute the pilot's maneuver, but also to counter any attempt by the X-29 to veer out of control.
New initiative in the artificial intelligence area, and it's called aircraft automation. The technologies that end up coming out of this would be autonomous flight vehicle technology.
URAS stands for Environmental Research Aircraft and Sensor Technology. Platforms that will fly higher and longer than the current piloted airplane, do science missions and other commercial applications.
Primarily the dull, dirty, and dangerous.
We can go all the way up to where the airplane can fly itself completely autonomously with no input from anyone on the ground.
Fly up to 50, 60,000 feet, fly a circle loop perhaps over a city, providing the capability that satellite does.
Now that we can fly for on the order of 8 to 10 to 12 hours, we can look at long duration processes, biogeochemical cycling, looking at carbon and nitrogen moving through an ecosystem.
To sort of kickstart a commercial UAV industry.
The technology that we've seen here in this task is what would be the foundation for a follow-on program to really address the issue of how can UAVs routinely operate in the National Airspace System.
The primary benefit of this technology is the ability of it to adapt to the unknown, whether it be a system failure, battle damage, icing on the wing, or flying in an unknown atmospheric environment.
The aircraft may be able to be flown, but the pilot may or may not be able to find a solution to how to fly that aircraft.
Neural net control systems where the controls are going to teach themselves and keep being smarter from flight to flight. It can reconfigure the airplane in an optimal way in order to give you the best flying qualities.
Okay.
There is no operator of the vehicle itself on the ground. Basically, the role that the human plays is more in managing the mission, an orchestra director, not the instrument player.
The vehicle will be positioned to hit the target.
One of the next things that we'll be demonstrating in UCAV is the collaboration amongst aircraft. How do sets of aircraft interact together in almost a social form?
We're going to examine the feasibility and technical utility of actually being able to fly two airplanes or multiple aircraft in formation with each other.
Now, the trick to this is to make sure that they fly in formation close enough that they can extract advantage without obviously running into each other.
The station keeping would be fairly close proximity for hours. The workload on the flight crew would be quite high, so we started to develop autonomous algorithms to do the station keeping. So basically we'll have an autopilot that you can engage.
The computers are flying the airplane without your stick input, even in the system, to allow a piloted airplane to take 2, 3, or 4 unpiloted vehicles on a long-distance trip.
We're just getting started on this technology. We'll use this technology to refuel unoccupied combat air vehicles.
The basket's slightly moving. Looks like it's going high. Okay, it detected a miss and came back on its own. So I did not do anything. She's got it. She's got it. Congratulations, guys. That was fantastic.
The Autonomous Soaring Project has one simple goal, is to program a small UAV to soar in thermals similar to the way a glider pilot or birds do. It has been reprogrammed to automatically detect that it's in an updraft and then use that updraft by circling. There's a wide variety of applications for this technology to help UAVs do things like forest fire detection, police surveillance, border patrol, and weather monitoring.
If the aircraft was damaged, you don't have to necessarily just rely on the pilot to compensate and fly the airplane. Adaptive flight controls, autonomous flight controls, different things where we're using the airplane to assist the pilot.
It will take over basically the controls of the airplane as far as flight stability.
The platform precision autopilot is capable of staying on a given path within about 15 feet. It allows the synthetic aperture radar system to fly over essentially the same path more than once. This obviously has some potential applicability when you're looking at Earth's surface movements, such as after an earthquake, or if you're looking at ice pack melting.
For the F-16, we went out and tested the system and based them on mishap cases. It prevented every single mishap. What we're developing here is merely an aid should the pilot get distracted or disoriented. By automating it, we can take out the pilot reaction time entirely.
The computer takes full control away from the pilot for a very brief period of time, and it redirects the trajectory of the aircraft to save the human.
ADS-B is automatic dependent surveillance broadcast. It's equipment on board an airplane that transmits its position and velocity information twice per second.
What we're really trying to is that we can use ADS-B as a way to do coordinated flight between multiple vehicles.
This system is present on a lot of manned aircraft, but we were one of the first UAS to perform testing of it in the national airspace. NASA has a project for integrating UAS.
So one day, UAS could hopefully fly with other commercial airlines and everybody will fly together safely.
There's various benefits to integrating unmanned aircraft, being able to monitor specific weather systems, monitor fires, delivering packages to your doorstep.
Operations to deliver medical emergency supplies, infrastructure, surveillance, and monitoring.
The technical side is a big challenge, but being able to integrate them safely is maybe even a bigger challenge.
To have thousands of these vehicles flying at the same time, you're going to have a lot more automation on the vehicle and in the airspace system.
Regulations for operations of the vehicle, regulations for airspace, regulations for infrastructure. These aircraft are going to be highly autonomous, piloted, optionally piloted, unpiloted vehicle.
It's not just looking at the UAM, it's actually integrating the small UAS, the package delivery, or even the larger cargo delivery.
Subscale aircraft, we use those for a variety of reasons. To test things like new technology, which could be hardware or software, or even a completely new vehicle. You can do almost anything you want without much risk. You can realize those gains very quickly. We're researching some level of autonomy. The aircraft, in most cases, are capable of taking off, flying around, and landing without any human intervention. Things like argue pilots and multi-rotors and flying computers are allowing kids to play with research-type tools that they never had access to before. So it's sort of driving in this new robotic learning type environment that never did exist. So it's sort of driving in this new robotic learning type environment that never did exist.
Station, this is Houston. Are you ready for the event?
Station is ready for the event.
Houston ACR, this is Mission Control Houston. Please call station for a voice check.
Station is ready for the event. Station, this is Houston ACR. How do you hear me?
Houston ACR, this is Mission Control Houston. Please call station for a voice check.
We hear you loud and clear. How about us? We hear you loud and clear. Please stand by for opening remarks.
Hi, my name is Dr. Deborah Taylor Long, and I am board chairwoman for the Gifford Youth Achievement Center, also known as GYAC. We are grateful for this extraordinary opportunity to speak with astronauts at the International Space Station. Now, here's our first question.
Hi, my name is Aiden Robinson. My question is, what type of food do you eat while in space?
Hey, that's a great question, and it's one of the unique things that we have to get used to while we're up here, because our food has to be packaged differently than it is on the ground. As a matter of fact, right here I have it's a container of pasta and turkey in here, so kind of like a spaghetti noodle type of thing. And so you can see it is, Jessica's going to bring it up to the camera, but it is hard. It's had all the water moved out of it. And so if she knocks on it, it's hard like a brick. And then what we have to do is we go up to a special machine that injects water into the straw end of it. And then we mix it up and we let it sit for a few minutes, and then it's just like eating it back home. But all of our food has to be contained in little bags like this. Otherwise, it starts floating away and it's hard to control. So no plates for us up here. Just eating out of bags, and really the only utensil we use is a spoon. So we carry around a spoon and then bags of food.
Hi, my name is Chancellor Braceley. My question is, can you hear any sounds in space?
Yeah, it's a good question, and certainly when we're up here on the International Space Station, we hear lots of sounds. It's actually quite noisy on the ISS with all of the different machines running, with all the science experiments that are going on. It all kind of creates a pretty loud background noise that we kind of hear all the time, but we can kind of tune that out so that we can hear the other sound that we hear a lot of, which is the ground. So we have speakers in each one of the modules on the ISS, and that is how we talk to the ground teams that help tell us what to do and where to find the things we're looking for. So we're super grateful for the huge team of people that help keep ISS operating.
Hi, my name is Christine Ashley, and my question is, how do you sleep in the space station?
Sleeping in the space station took a lot of getting used to, at least for me. So we have sleeping bags. They're blue sleeping bags, and we have a small little crew quarters that's like a little closet, like you can see on the screen here. And the sleeping bag has little armholes in it, and we can tuck ourselves in there. And some of us like to free float inside our crew quarters, and others strap it to the wall so that we're kind of secured in one spot there. But it's pretty cozy, keeps you pretty warm, and after a couple weeks of getting used to it, you can sleep really, really well.
Hi, my name is Adriana Clark-Hess. My question is, how do plants grow in space?
Well, that's a great question, and it is something that we're spending a lot of our time and energy on right now. Once, as NASA starts to pivot towards going to the moon and eventually to Mars, plants and growing plants is going to be a big part of that capability to provide not only food, but be part of the life support system, producing oxygen. We are doing an experiment right now, just behind the camera, called X-Roots, which is experimenting on different ways to provide water to plants. As you know, there's no gravity in space, and so you can't just pour water on the plants. And we've learned that plants don't necessarily need gravity to know which way to grow, but they do grow their roots towards the water supply. And last year we grew some chili peppers, which apparently were really, really hot. We've had some of our colleagues that got to taste test those things. Jessica and I and the rest of our crew have gotten to grow some lettuce and some radishes over the last few days. And it's really exciting to see those things. We got other living organisms up here, so it's really fun to be able to take care of those and watch those things grow and practice getting our green thumb.
Hi, my name is Caleb Baker. My question is, what equipment do you use to breathe in space?
So inside the International Space Station, we have an environment where we have just the right amount of oxygen and nitrogen for us to breathe. So inside the ISS, we have a very Earth-like environment. Of course, outside the ISS, out in space, it's a very different story. And so when we go out on our spacewalks or our extravehicular activities, we have our spacesuits that we wear, the big white puffy suits. And the backpack on the back of those suits contains the life support system for us, which basically means it contains the oxygen that we have to breathe, as well as the mechanism for scrubbing out the CO2 that we breathe to enable us to have the right amount of environment and air to breathe while we're out on the spacewalk. So there's enough in there for us to be outside for around 7 hours or so to get a lot of work done while we're out there.
Hi, my name is Jacqueline Harris. My question is, how do you drink water in space?
That is a great question, and it's one of the things that we can have the most fun with up here, because water behaves very differently in space. Instead of going to the bottom of a container, it'll just float inside the container. And so a typical water bottle doesn't work quite as well up here, because it's hard to get the air away from the part that you want to drink water out of. You can spin it and it'll separate, and so the water tends to go to both sides of it. But water bottles are kind of difficult. So what we have mostly up here are drink pouches, and so we get a whole bunch of these. Sometimes they're juice. We have coffee and different things like that. This one is just water, and we put a straw into it. We put it into we plug it into the same machine that we do the food, and it fills it up with water, and then we can squirt our water out like so. And so it's kind of fun. You can get these bubbles that are just floating around up here, and play with them. But they can also make a big mess. But it's really unique. You can see the water just forms a perfect sphere up here, and will float around until we drink it.
Hi, my name is Kendall Melton. My question is, how was the docking at the space station?
Yeah, it was really neat getting to dock to the space station. As we were coming in on our SpaceX Crew Dragon, which we've named Freedom, as we were approaching the ISS, it was really neat to see the ISS in the blackness of space, just nothing out there, and the ISS appeared as a super, super small gold kind of imprint on the back of the night sky. And to know that that was our destination, that was going to be our home for the next several months, to be able to kind of see it appear a little bit out of nowhere, was just amazing. And then to, of course, get closer and closer to it, and slowly approach and then have a successful dock was just awesome. And then to get to come onto Space Station and greet all of our friends from Crew 3 and Expedition 66 and 67. It was just an awesome memory to be able to embrace them when we arrived.
Hi, my name is Caitlin Powell, and my question is, why do astronauts dream underwater?
Well, that's a good question. We train in the water and underwater specifically to get as close as we can to simulate weightlessness, especially for long periods of time. So to practice for spacewalking, we have a gigantic swimming pool that has a full-size mock-up of the International Space Station in it, and we get in in the spacesuits, and we go down there, and we'll be in those suits for 6.5 or 7 hours for each training event, and the divers that are out there assisting us help us get weighed out so that we're neutrally buoyant, so we don't float to the top and we don't sink to the bottom, and that simulates weightlessness as close as we can get on Earth, and it allows us to practice all the intricate tasks and teamwork that we have to do when we go out the door for a spacewalk.
Hi, my name is Landon Cheney, and my question to you is, how is food delivered to the space station?
We are super lucky up here that we have cargo vehicles, so spacecraft that come up and deliver supplies and hardware, science, and also food. And so the next one coming up will be SpaceX Dragon 25. That will be coming up in the next couple of weeks here, bringing lots of things, including food. So we are super grateful for that opportunity and that capability to bring us food. And then in addition to kind of our standard menu of food, like the turkey that Bob was showing you earlier, sometimes these cargo vehicles also bring us treats. Sometimes they are allowed to load at the last minute some fresh foods, so some things like fruits or even ice cream that we might, hopefully, we've got our fingers crossed, that we might be able to get some on our next cargo vehicle.
Hi, my name is Ria Coco. My question is, what are the job duties you have in space?
Well, one of the really fun things about being up here is that no day is the same. We take part in so many different tasks and perform so many different science experiments that there's just so many different things to do. Some of it is maintaining the space station and fixing things. The space station is, a little over 20 years old now. So just like a 20-year-old house, it has things that need taken care of and modernized and repaired. And so we do things like that. And then also upgrading things and making and installing new software and new hardware on the space station. And then, of course, at any given time, there can be 250 to 300 different experiments on board. And so we end up being the people that run those experiments, and sometimes we're taking part in those experiments ourselves as part of the human research program. So we, take part in different things that look at how the human body responds to being in space for an extended period of time. So any given day, we can be a repair technician, we can be a scientist, you name it. And we touch all different forms of science out there, from materials science and developing new ways to form different materials, all the way to medical science. The opportunities are endless. There's just so many different things that we get to do up here.
Hi, my name is Jamar Alston. My question is, how hard is it to move around inside the space station?
So if you were to ask us that question when we first got here, the first week or so, our answer would definitely be that it is pretty tough. But with time, just like with anything, we have definitely adapted and learned how to use all three different planes, the whole volume, and learned how to float effectively. So we use all of these handrails that you can maybe see to kind of hook our feet onto, as well as our hands, and kind of Spider-Man our way through station. So it's super fun to learn how to move in microgravity.
Hello, my name is Lenore Carter. My question is, when you're exiting the Earth's atmosphere, do you feel heat?
That's a good question. On the way uphill during launch, we don't really feel too much heat, and part of that is because our vehicle is starting out very slow and gradually accelerating as we get higher and higher. Plus, we have the vehicle around us. So in our seats, we have very good air conditioning. We're protected by our suits, and so we get to just enjoy the ride and the incredible acceleration that the rocket provides. And it was just such an amazing experience. Feeling the rumble and the thrust and the acceleration as you're getting pushed back into the seat was just absolutely phenomenal. And then at an instant, the engines shut off, and you go from feeling 5 Gs of force on your body to instantly being weightless, and it was absolutely spectacular. We'll let you know in a couple months on our way home whether we
Good afternoon, Mr. President, Madam Vice President, everyone. Thank you for joining us. This is an historic occasion. We are here to view the highest resolution image of the infrared universe anyone has ever seen, captured by the most powerful telescope anyone has ever made. I am proud to turn things over to a president and a vice president who have charged the entire Biden-Harris administration with leading with the science and who believe deeply in the power and possibilities of science and technology for all of us. Madam Vice President, we particularly appreciate your leadership of the National Space Council and your commitment to ensuring innovation in space. The floor is yours.
Thank you. Thank you. Well, good evening, everyone. I am very honored to be with you all. President Joe Biden and I talk often about our mutual passion for everything you all do. This is a very exciting moment to join you for the unveiling of the work that you have been laboring on for decades. So to our President Joe Biden, thank you for your leadership around all of these issues. Our NASA Administrator Bill Nelson and the Office of Science and Technology Policy Acting Director Dr. Alondra Nelson. Thank you also to our colleagues from across the White House and NASA and everyone else joining us from home. So yes, as chair of the National Space Council, I know that today represents an exciting new chapter in the exploration of our universe. From the beginning of history, humans have looked up to the night sky with wonder. And thanks to dedicated people who have been working for decades in engineering and on scientific marvels, we can look to the sky with new understanding. When NASA launched the Hubble Space Telescope in 1990, we were able to see the stars unobstructed by the Earth's atmosphere and understand the universe in ways we could have never imagined even a few decades earlier. And now we enter a new phase of scientific discovery. Building on the legacy of Hubble, the James Webb Space Telescope allows us to see deeper into space than ever before and in stunning clarity. It will enhance what we know about the origins of our universe, our solar system, and possibly life itself. This was made possible by partnership among nations, and it is an example of how the scientific endeavor can build upon the international rules and norms that govern our cooperation in space. This telescope is one of humanity's great engineering achievements. And the images we will see today are a testament to the amazing work done by the thousands of workers across our nation who dedicated years to this project. They embarked on this complex endeavor for the benefit of humankind, and in the process accelerated American innovation, strengthened partnerships with our allies, and will undoubtedly inspire generations to look to the heavens with excitement and ambition. With that, it is my great honor to introduce a leader who has always believed in the power of American innovation and international cooperation to achieve the remarkable, our President, the President of the United States, Joe Biden.
Well, it's great to be with you all. And I was going to say good afternoon, but we're starting this meeting late because I was engaged in preparing for a trip to the Middle East. But today is a historic day. And thank you, Vice President Harris, Chair of the National Space Council. And thank you, my dear friend and our outstanding NASA Administrator, and the only guy here that's been in space, Bill Nelson. Bill, you're a good friend. Thank you very much for what you're doing. And Dr. Nelson, you're doing a great job leading this Office of Science and Technology and Policy. It really is a matter. It really is amazing. 6.5 months ago, a rocket launched from Earth, carrying the world's newest, most powerful deep space telescope on a journey 1 million miles into the cosmos. First of all, that blows my mind. 1 million miles into the cosmos. Along the way, unfolding itself, deploying a mirror 21 feet wide, a sun for science and technology, for astronomy and space exploration, for America and all of humanity. You know, as an international collaboration, this telescope embodies how America leads the world, not by the example of our power, but the power of our example. A partnership with others. It symbolizes the relentless spirit of American ingenuity. And it shows what we can achieve, what more we can discover, not just about distant places, but about our very own planet and climate, like NASA's Earth Systems Observatory that we launched last year. That's why the federal government must invest in science and technology more than we have in the past. These images are going to remind the world that America can do big things, and to remind the American people, especially our children, that there's nothing beyond our capacity, nothing beyond our capacity. We can see possibilities no one has ever seen before. We can go places no one has ever gone before. You know, you've heard me say over and over again, America is defined by one single word: possibilities. Possibilities. I want to thank the team at NASA for once again showing that that's who we are. That's who we are as a nation of possibilities. And now let's take a look at the very first image from this miraculous telescope. NASA Administrator Nelson, I'm going to turn this over to you. So will you please tell us about what we're seeing?
Mr. President, if you held a grain of sand on the tip of your finger at arm's length, that is the part of the universe that you're seeing, just one little speck of the universe. And what you're seeing there are galaxies. You're seeing galaxies that are shining around other galaxies whose light has been bent. And you're seeing just a small little portion of the universe. You know, 100 years ago, Mr. President, Madam Vice President, 100 years ago, we thought there was only one galaxy. Now, the number is unlimited. And in our galaxy, we have billions of stars or suns, and there are billions of galaxies with billions of stars and suns, and we're getting our first glimpse. As you said, Mr. President, we're looking back more than 13 billion years. Light travels at 186,000 miles per second, and that light that you are seeing on one of those little specks has been traveling for over 13 billion years. And by the way, we're going back further because this is just the first image. They're going back about 13.5 billion years. And since we know the universe is 13.8 billion years old, we're going back almost to the beginning. That is the discovery that we are making with this. There's another thing that you're going to find with this telescope. It is going to be so precise, you're going to see whether or not planets, because of the chemical composition that we can determine with this telescope of their atmosphere, if those planets are habitable. And when you look at something as big as this is, we are going to be able to answer questions that we don't even know what the questions are yet. This is what's happening. And it's because of this wonderful team that's out here. Part of that team, led by Thomas Zurbuchen, it was in trouble financially 5 years ago. He took it over. He got Greg Robinson, that you're going to meet, to direct it, and the result is what you've seen. So what an incredible team, joined, by the way, with our international partners, the European Space Agency and the Canadian Space Agency. So this is an international endeavor.
It's amazing. I wonder what the press like in those other places.
time for the press to leave, and then we'll continue the briefing.
considered how big breakthroughs in science, engineering, and medicine occur. The popular misconception of how a breakthrough happens is perhaps a eureka moment while working on a project, and in that instant, the next big thing is born. Although that may happen sometimes, the truth is that most big breakthroughs are not eureka moments at all, but actually take years of painstaking work, trial and error, and rigorous testing before the finished product is ever realized. Researchers in the world of engineering and science almost always move in small, incremental steps, slowly building the case for these new revelations until they are sure the research is ready to be shared with the world. Then, and only then, is when we in the general public hear about it. Although it may not be quite analogous, just think about the moon landing as an example of this phenomenon. Most of us are familiar with Neil Armstrong's famous words when he first stepped onto the moon.
It's one small step for man, one giant leap for mankind.
For those watching it, that moment may forever be viewed as perhaps the most tremendous scientific and engineering breakthrough in the history of the world. Clearly, that event was enormously important for many reasons, but that first step on the moon was actually the culmination of millions of smaller incremental steps from tens of thousands of others that allowed it to take place. This basic idea is true for all scientific study. Researchers and engineers generally take an idea and meticulously study it to make sure that all bases are covered before new technology reaches the general public. NASA's Environmentally Responsible Aviation Project team members are following that same philosophy as well. This team has been working for years to find ways to reduce aircraft drag, aircraft weight, fuel consumption, engine emissions, and aircraft noise. In order to achieve these lofty goals, the team did, in fact, take incremental steps to make sure each project was viable. Now, toward the end of the ERA project, the team is ready to take the lessons learned from the smaller tests and begin putting all the pieces together, preparing to show the world the next big thing in aeronautics. NASA X has been at the forefront of the ERA program since its inception. This 6-year endeavor has progressed from innovative ideas to multiple designs, wind tunnel tests, and actual flight hardware. And the aerospace industry has taken notice that these technologies are ready to dramatically improve aircraft efficiency. Part 1 of this episode of NASA X looks back at some of ERA's earlier tests to see how those early successes and failures paved the way to the larger, more advanced tests of today. And we will see what the future holds for many of the ideas and technologies that have been developed by some of NASA's best and brightest engineers and researchers. When the Environmentally Responsible Aviation Project was first implemented, it was clear the stated goals would be hard to reach. The team was tasked to reduce aircraft drag by 8%, reduce aircraft weight by 10%, reduce fuel consumption by 15%, reduce emissions by 75%, and reduce overall aircraft noise. The difficulty of making such dramatic improvements was the fact that many in the aviation industry believed that the modern tube and wing-shaped aircraft had reached its maximum ceiling on efficiency. When NASA first undertook this challenge, they realized they would have to bring an A-team of NASA engineers from numerous NASA field centers, along with highly skilled teams from industry and academia, in an effort to find these new efficiencies.
We've got new airframes,
8 different technologies that we worked in phase 2, a myriad of 60-something technologies we worked in phase 1 and we looked at. And we will be delivering at the end of this year technologies that say we can meet all of those goals. So it is an unmitigated success, and every one of our partners in this is getting something out of it.
Some of the major areas of study for the team included looking at engine redesigns, airframe redesigns, materials testing, and even developing new aircraft that integrate the wings into the aircraft body to increase efficiency. This unique design is called the HWB, or Hybrid Wing Body Aircraft. The HWB began its life as a series of computer models and then was upgraded to sophisticated wind tunnel models. Once the team was satisfied the HWB concept showed significant promise, it was upgraded to a flying scale model aircraft. 122 times the hybrid wing body models flew over the dry lake bed in California, where so many previous X-planes had flown before. And with each flight, the engineering data helped validate this unique type of aircraft design. Researchers feel confident that the strides they have made in this aircraft design will pay huge dividends in the future. Just watching footage of early aircraft shows how far we've come in only 100 years. As an example, most early planes were made out of wood and canvas, but as planes became more powerful and efficient, materials began to change. Today, we're aware that most planes are made out of lightweight aluminum skins, but the industry is moving toward the use of composite materials now as well. In fact, the Boeing 787 was the first all-composite airplane ever produced, and it took its first commercial flight on October 6, 2011. Although this plane is state-of-the-art, NASA's ERA planners believe that they can improve the strength of composites while making them safer as well. The idea they're investigating is called Perseus, or Pultruded Rod Stitched Efficient Unitized Structure. Early testing began with small pieces called coupons. They were developed to a point where researchers believed they could be tested on a larger scale. NASA's team built larger test sections and eventually brought them to this lab for stress testing. With this test, designed to bring the article to failure mode, the team applied pressure until the piece snapped. The data was used to further validate Perseus, and now the team has decided to build and break a nearly full-scale piece of Perseus material.
NASA and Boeing have been working together for quite a few years developing lightweight structure for commercial transport aircraft. What we're seeing today is the final piece of a project called Damage Arresting Composites, where we're trying to develop a new structural concept that will be applicable to lightweight structures for commercial airplanes. And what you see here is a 30-foot-long test article that we'll be testing at the NASA Langley Research Center by applying the kinds of loading that it would feel if it were in a real airplane.
But with a piece this large, a major hurdle lay in front of them: how to get the piece from California to Virginia for testing. Traditional methods like trucking and train travel would not work due to bridges, overpasses, and some road weight restrictions. The solution was to fly it across country. But no ordinary aircraft would do. Ultimately, the team enlisted the service of NASA Johnson's Super Guppy aircraft for transport across country. This Cold War-era aircraft was specially designed with a hinged front-loading system that could just barely accommodate NASA's cargo. It was not lost on team members that this old and slow beast of an aircraft was transporting a test article that will undoubtedly be used in many aircraft of the future. On a cold December night, the aircraft landed in Virginia for an early morning offload. Here is Dr. Faye Collier to explain what is next for this test.
Today we're
here at Langley Field, unloading the Perseus multi-bay Colts, multi-bay box that will be tested in the Colts facility. So we've been working on Perseus for about 10 years now, partnered with the Air Force, partnered with Boeing, R&T, and we started off with small coupon testing to prove out the concept. We built a small box